Hello, programmers. In Lab 7 this week, we are going to read live data straight from the US Census. So what I'm going to do is just walk through this notebook, which shows us how to get very simple data at the various geographic levels, just to get a sense for how the Census API works, right? So we're really just going to be looking at one variable, which is the population size in different areas. And let's just get started. So the first thing, to follow along here, you will need to sign up for a census key. Click this link, you put your organization, your email, you submit it. They'll send you an email and you will have to activate your key, and that will have a large number, looks something like this, and that will be your key. So when you run this lab, you will have to change the data here on line 10 with your census key. All right, this is just a made up number, and it won't work until you put the real key in. Now, I'm storing my key in Google Colab under a variable name called Census API key. And if you want to, you can do this. It's actually quite easy. That way you could share this notebook with someone else, but they would have to use their own census key the same way that I'm asking you to. So to do that, you see here on the left side, you would click this, Secrets. You would give it a name, right? You type in the value, you would actually paste it, right? And then there you go. That is now a secret that you can use in all of your notebooks. And when you want to actually use it, though, you have to grant access to it. And the way that we access a key is you import this library from Colab, and then you call userdata.get, and you just pass in whatever variable name you gave your key. You put it in there. All right. So I don't need this one. I named mine census _ API _ key. And you can see it's in here and it's hidden so that my key remains secret to me. All right. So here's what we're going to do in this video. We're going to talk about geographies a little bit. We're going to do our first API call to get a sense for how this Census package. And Census is a Python library that just makes it a little bit easier to work with census data. The US Census itself has what's called a REST API, where you send requests to it just using HTTP, just URLs, and it gives you data back, right? So these are the variables, and I'll just show you. If I click on one, this is what it looks like. So I send this request, and it gives me this data back, which is basically a Python dictionary, right? So this is called JSON. And it's a format that's used to send plain text data or to save it. And we've already been looking at some JSON in our class this semester. Okay, so Census is going to help us just read the census data in a more Pythonic way using Python. There's some standard data in this US package, which aligns common names for states and things like that with the numbers that the census use. They're called FIPS. I actually don't know what that stands for. Maybe we can look it up. All right. So get your key and set it up. Then we're going to make our first API call. And if you can't do this, then you need to get your key working. Make sure that you can run this code. All right. So we install our libraries, we read our key, and then the basic steps for calling the API work like this. You set up your API key and you load it and you save it in a variable. You create a census object from the Python library. The common name for it is just C. You identify the variables you want to look up, and we are looking up a variable, this one, B01003 _ 001E. Now, I'll give you a little bit of information about census variables. This first part is the table or the concept. And then the second part is the specific thing that it measures. So this concept or table is the population. And then this is the estimate, that's what the E means, for everybody in a geographic area. So all genders, all ages, all race and ethnicity, any other breakdown that they might have. Now they're going to be 001, 002, 003, and so on, which will tell us subgroups of that population. So we're just going to work with this one variable today. And I'm going to show you what kind of data we get back. So we run this, right? And this is what the data that comes back from the census looks like. It's a list. We see the square brackets. And then each list has key value pairs, right? We've got the name is Alabama. B001003 is, looks like 5 million people in Alabama, right? Right. So that's the population. And then we get back the state and so on. So if we look at our steps, we get the variable, that's total population. We identify the geographic places we want to query, right? So we're passing two named arguments in here. One is fields, and these are the fields we want to get back, right? The variables. And then one is geo, and that's the geographic location that we want to search for. So we're going to say for every state. So state : star means every state. And then we say what year data we want, and I'm just using 2022 in all of my queries here. All right. So this is our very first thing. Then typically we send the request, we get the results, we convert it to a data frame because then we'll be able to use all of pandas to do it. We're going to want to rename the columns, and then we can clean the data if we need to. When I say clean data, I mean things like parse out names, change the data types, and drop rows that don't make sense, maybe merge some other data in with it. Just get our data ready for analysis. Okay. So now we read the raw data. It looks like this. And we're going to convert that to a data frame. All right. So our data frame, before we rename the columns, has these columns: name, the variable, and state. And we get them because we passed in the fields name and the variable. So they are going to be columns in our data frame. And we're going to get state because that's the geographic area that we wanted to search for. Okay. So now we're just going to give it better names. We've done this before. We get our data frame. So first, we create a new data frame on line 1. On line 2, we rename it. We pass in the columns. So the key is the existing name. The value is the new name. So I decide that I want to call name state name. This value in state, I'm going to call that state FP for FIPS. The variable name, I'm going to rename to total pop for total population. And in place just means just do it to the data frame, modify the existing data frame. Don't return a new one with the values. All right. Now the next thing here, line 3, let me just put a comment in there. Convert total pop from a float to an int. So if we look at our raw data, our unclean data, we see that the population is all 0.0. But this is the actual estimated population, and they don't estimate them in fractions. They're all whole numbers. So I'm going to convert it to an integer. And I do that by, say, df for my data frame, total pop for the column name or the series. And then I use this method as type, and I give it the type I want to convert it to is an integer. And because they're all numbers, there are no errors. It works easily. I get no problems. And I can look at the first 10 states. Now, I have not ordered my data frame, so I see that the census has returned it to me in alphabetical order, which is great. It's fine. Okay. So we've made our first call, and we've converted it to a data frame, and we've done this at the state level. Now, if we take a look over here, this is from the Census API documentation. It tells us what geographic levels we can do. So we've done state so far. If we wanted the entire nation, we could do it for the whole nation. And in this video, we're going to look at state, county, place, tract, and zip code. But just so you know, there are a few other areas like congressional districts, American Indian reservations, and then metropolitan, micropolitan statistical areas are where they group like a city into the larger metropolitan area. So you can get like Los Angeles and all of the smaller cities that make up LA as one metro area. All right. So that's actually an interesting stat for us to look at, or geographical region for us to look at. But I'm not going to demo that in this video, but it'll be easy for you to do it once you understand these concepts. All right. So now we're just going to go down and we're going to learn a couple things as we go through the different regions. In our next section, we're going to look at getting data at the county level, but we're also just going to clean up our code to make it a little bit more reusable. And you can read this on your own. I'm going to talk you through it anyway. So we create the census object. We don't need to recreate this. I just did it here so you could copy and paste this whole block. But once you create it, you don't need to recreate it every time. We could just reuse the variable. So I'm creating a dictionary with keys on the left, colon, values on the right. And these are going to be the variables that I want to look up, the fields that I want for the census. And on the right side, the values are going to be the columns I want to rename them to. All right. So if I want just the keys, I can get them by calling the field names object. I call the keys method on it. So once I run this function, I'm going to convert it to a real Python list, and I'm going to call that fields. So far I've got my census variable, my fields variable, my field name dictionary, and my fields list, right? Now, I don't want to get every state because there are too many counties in the whole country. So I'm just going to get two states. We're going to get all the counties in New York and in New Jersey. And I'm creating a new variable called state FIPS, and it's going to be a list, right? I've got these square brackets. Lets me know it's a list. And I'm using this US package. So every state is an object in here. And once you get like New York, you can get the FIPS number, you can get the postal abbreviation, you get the full name and things like that. So in my list, I'm going to put the New York FIPS and the state FIPS. And we'll display that so you can see. All right. So when I run this code, you can see this is just going to be a variable with two numbers in it that indicate New York and New Jersey. And when we saw our states data, we can see Alabama's 1, Alaska's 2. So New York is 36. Jersey's probably around there also. I'm not even sure. Okay. Now, here's how we build the query. We say the fields we want to get. So our fields are going to be name, state, and the variable name. And they're in a variable called fields. And then the geo, we're going to say for every county, like we did for every state. And if we did this, just this part, we would get every county in the entire data set. But we don't want that. We only want it to be the counties that are in the states, right? So I'm doing something a little bit new here. We're using an F string, which is not new. And then we're going to call this join function on the string. So I've got the string literal here, which is a comma. And I'm going to join my list. And that's going to return a new string with the items in the list separated by a comma. All right. Actually, why don't we do that up here so you can see it? All right, we'll call that here. Okay. So we get the data into this data object. We use the pandas data frame to create a new data frame. I'm calling it counties. I'm going to add a field name. Well, we can comment that out, and I'll show you what I'm doing. So let's just run this, see where we stand. All right. So these are the FIPS. See, they're 36 and 34. That's New York and New Jersey. They're separated by a comma. And that's what's going to go in here. So state is going to be colon 3634, right? And that's going to tell the census API which states we want to get the counties for. So every county in states 36 and 34. All right, and then here's what our data looks like before we clean it and rename the columns. And you see, we always get the geographic area. It comes back. It comes back in our results. So since we're asking for county and in-state, we get state and county for us for free. But the county, what they call the county, is the county FIPS. So I'm going to rename that to be county FP. And I don't need to ask for county because I'm getting it for free. I'm just going to pop it into this dictionary later. So line 19 says, in the field names dictionary, create a new key called county and assign a new value to it called county FP. So once we do that, we're going to do what we did before, rename them, convert total pop to an integer, and then I'm going to sort them by size, right? So we're going to get largest to smallest counties in New York and New Jersey, and we're going to show the top 10. It's taking a little longer than I want, so I'm just going to run it again, see if there's something going on. There. Yeah, it shouldn't take that long. You can always click the stop button and retry it. Okay, so Kings County, that's Brooklyn. The largest population, 2.6 million. Then we get Queens. Then we get Manhattan. Then Suffolk. Then Bronx, Nassau, Westchester, and so on. And our first Jersey County comes in here with just under 1 million people in Bergen County in New Jersey, right? All right. So this is more kind of professional, what it looks like, what we're going to do going forward. We get our Census API. We've loaded our API key. We create a dictionary with the field names that we want to query and with values for how we're going to rename them, convert it to a list. Then we set up our whatever. We're going to have to do some setup for the geographic areas we want. We run the query. We convert it to a data frame. If we need to add new field names to the dictionary so we can use it to rename columns, we do that. I'll put a comment. Okay. And then we just take a look at it. We clean our data a little bit. Now, let's just take a look at this data. The county name says Kings County, comma, New York, Queens County, comma, New York, New York County, comma, New York. So we're actually going to clean this data a little bit more. And I'm going to create some functions down here that give us better data to work with, right? So there are a few things I want to do. I'm going to create a new field called county that has just the county name, and a different column called state name that has just the state. And then I'm going to take state FP and I'm going to look up that state and return the coastal abbreviation. So once we're done with this, right, we're going to have a data frame that has the state, just the county, the total population, the state FIPS, the county name that was returned, and then just the state name, the full name, and the county FIPS that was returned to us also, right? And, well, I'm reordering the counties here, but I'm going to put state FIPS at the end. That's a better place for it. Okay. So we've done this already. We're going to use apply. So I wrote some functions here. I wrote 3 different functions, and I'll walk you through them pretty easily. Remember, our data looks like this. So we're going to apply parse county to the county name, and that's going to break this county, Kings County, New York. So it just says Kings. So it just says Queens. So it just says New York, and so on. So what we do is we're going to split it at the comma, and that gives us 2 parts, right? The part before the comma is part 0, and the part after the comma is part 1. And then I only care about part 0, the first part, or the 0th part. So I'm going to replace the exact string, the part with county, with nothing, and then I return that name, right? So I clean this up a little bit, and that gives me just the short county name without the county or the state. Now, for parse state, we're going to do the same thing, but the other way. This is easier. We're just going to use the part after the comma and return that. So we create a new column called counties, and we assign county name apply parse county, and then state name, and we apply parse state. Now, here, we just write a little function to use the US package to look up the postal abbreviation. So first, we check to see if it's a state. So we do us.states.lookup, and we look it up based on its FIPS. And if we find it, so if that state is not none, then we return the abbreviation. So once we if we hit line 16, our function stops running. If we didn't find it, then we try to find the territory, and we look that up by the state FP, by the FIPS code. So if we found a territory, we return that abbreviation, and our function stops running. Otherwise, if we couldn't find it in the states or territories, probably we have an actual error, or there's something wrong, or we're misunderstanding the packages. And we just return an empty string. So that would be blank. And maybe we want to filter out that data, or we could do something else with it. But for now, we're not too worried about it. So we apply that to the state, and that's how we get this nice state column with the state postal abbreviation. All right. So I think everyone understands what counties are. We have census tracts, and a census tract is a smaller by population area than a county. So census tracts are geographic regions that the census uses across years so that we can measure the same general area, but they can redefine them as well. But each tract has about 3,000, 5,000 people in it, somewhere in that range. So in a dense area like Brooklyn, where I am, the tracts are very small. There'll be a couple city blocks. In a more sparsely populated area, there'll be very large tracts of land area-wise that aren't very densely populated. So the tract isn't based on its geographic size, it's based on the population size. And tracts are a good discrete level to look at data when we're looking at census data. There's one smaller area called the census block, which doesn't always, it's not always surveyed in the surveys. So sometimes if you want very precise data, you can use blocks, but you have to be a little more careful as to whether you're going to be able to get enough data across different years and different regions and so on. All right, so here's how we get the tracts. We are just going to get them for a few counties, just the Long Island counties. So we're going to reuse the data we just queried, right, which is in a data frame called counties. And I'm going to do a filter with a logical AND where I get the counties in New York and where the county name, right, county, that's how we rename them, is either Nassau or Suffolk, right? And then I create a list of just the FIPS because that's what I care, the county FIPS. And I'm going to convert that to a string like we did before. So it's going to be one single string with the county FIPS separated by commas. Now I get the names I want, all right? So the name that's returned by our query is going to be the tract name because we're querying for tract. We'll get the state, and we're going to rename that to be state FIPS, county to be county FP, and then of course our total population for the region. We're going to rename that to be total pop. All right, we get the fields, we run our query. Now, this is the first time where we're doing two things. We're going to get the tract, but we say in the in part, we say the state is going to be New York only, and the county are going to be these county FIPS. All right. And then again, we convert it to a data frame, we rename it, we clean our total pops, we sort them by value, and then we can filter down. We're going to actually have a couple repeats of state and county because they're going to be returned with the in clause. But since I asked for them, I can just rename them here and get the tracts, just the ones I care about, in the order I want. Make a nice data frame where I get the tract number, the census tract name, total population, right? Now the next layer we're going to look at are places, and places are what we've been using in a lot of the labs so far. We've been looking at places that have more than 100,000 people. So I essentially ran this query on all of the United States, and then I did a filter after I got the data on the population size, right? But what we're going to do here is get every place in the state of New York, create the dictionary, send it to a list, get all the places in New York. So place is just called place. We're using the New York FIPS. And again, clean, rename, and so on. And here we're looking at the tail. So we have one place, Daring Harbor, and that has 0 people currently in it. Saltaire out on Fire Island has 2 people in it, right? So these are our smallest places in New York, the bottom 10. Now, one thing, and we didn't do it, we didn't clean it, but if you see the way this data, we could parse this to get more information, right? So the place name is actually this part here. So Fisher's Landing, that would be like the common name for the place. And then this part tells us what kind of place it is. Is it a city? Is it a village? Is it a CDP, which in the notes I tell you is a census designated place, right? And let's switch this to head and we'll see. That for the bigger ones, we get New York City. Buffalo is a city. So all the big ones, their place type is city, except for this upstate census designated place, which actually has 76,000 people in it. So it's a pretty big place, and it kind of slides in with our cities here. So these are the biggest cities in New York, including this CDP, which is a place and not a city, right? All right. So if we wanted to parse this, we could do the same thing we did with the counties. It would be a little bit trickier, but we'd get New York, then we get the type of place it is, and then we could get the state name out of there and make new columns. So eventually we could filter it based on city or village or CDP and so on. All right. The last thing I'm going to show you how to do is to get zip codes. Now, I say zip codes are a little weird. They are good to work with because people understand zip codes. They know their own zip code. They know the zip codes near them. They're also small. In New York, they're a little bit bigger than our tracts are geographically, but generally zip codes are a fairly compact area, so we can get granular data by looking at them. But zip codes can kind of They don't match up with the other geographic boundaries, so they can be partially in one county and partially in another county. Things like that kind of mess them up a little bit. So let me fix that. That should just be zip code. So we're just going to get the name, which is going to be the actual zip code, and we're going to get the total population, right? Now, we're going to do a little bit of work here because I want to get the zip codes. I don't want every zip code in the country or every zip code in the state, but I can't filter them by county. It's not allowed in the census because they're not wholly contained within counties, and counties aren't wholly contained within them. So the smallest region I can get is the state level. So what we're going to do is look up, I created a data file for you guys, which has the zip codes and all of the counties that they touch and the states in here, right? So we're going to read this as a data frame, and then we're going to list the counties that we want to see. And let me just show you. Let's just take a look at zips. So this is the raw data we get back, right? We got these columns: zip code, the county FIPS, the county line. This is, I think, from the postal office. I got this, and that's what they call the county, right? So one zip code, you can see, can be in a couple different, can appear a couple different times because it's in different counties or so on. Although you see we've different county FIPS. All right, so what we're going to do is take this data, and then we're going to run a plain old data frame filter on it so that we get just where county line is in the county names we care about, right? So every time Suffolk County appears, we're going to get that FIPS code, right? So when we run this, here's what our data looks like, right? So these are all New York County line. These are the county code, and there are a bunch of different zip codes inside of New York County, which is Manhattan, right? Oh, so the counties I selected are the 5 boroughs: New York, Brooklyn, Queens, Bronx. Richmond is Staten Island. Westchester County, our northern neighbors, and then Nassau and Suffolk on Long Island, right? So now I know all of the zip codes. I'm going to create a list with those. And let's do the join up here the way we did with the other one. I think that's nicer. So we're just doing this in a couple stages. First, we get the list. Then we're going to join that list into a single string. We run our query. So our fields, same as we've been doing every time. We say for, and then zip code is zip code tabulation area. And then we pass in just the zip codes we want. So we're not filtering it by state. We need to know the actual zip codes. And that is how we get these zip codes out of it, right? Okay. We put them into our data frame, and we can see I renamed that column. So zip code 10467 has the largest population in this data set, right? And then we got several zip codes that have no population. All right. So that is this lesson, this demo. And what we're going to do soon is look at how we join these with geographic data. And I'm going to prepare a bunch of different geographic data files for you to use and document that, because generally the geodata is not as readily available as a direct call to the census. Typically we need to download that and then clean it and prepare it a little bit. So in this video, we learned the basic steps of querying census data using the Python census package. And we got a better understanding of how to limit our queries to specific geographic areas and how the census understands those areas. Enjoy coding. Let us know if you have any problems with your Census API key or running this code. Remember, this code will not run until you have your own Census API key. That's it for today. Good luck and have fun.